The sine law. Our learning goal today is to solve acute triangles using the sine law. Please ensure you have the lesson printout so you can follow along with this video. Recall labeling triangles. The vertices or angles are labeled with capital letters when we are labeling a triangle. The sides are labeled with lowercase letters, which are always opposite of their associated angle or vertex. Let's try labeling some triangles. Example 1. Completely label these triangles. Here we're given the three vertices of this triangle, P, Q, and R. We know that across from each of these vertices is our sides, and they're written in lowercase letters. For example, you see capital P here, so lowercase p will be over here for this side. On this side here, we have capital Q, and so the side associated with that would be lowercase q over here. And here we have the vertex R, and opposite that is our side R. Let's try another example. Here we're given all the sides, X, Y, and Z. We know X, this side, is going to be opposite the vertex X. Y is going to be opposite the vertex Y. I'll write that in a capital letter. And Z, side Z, is opposite of vertex Z. One more example. Here we're given one vertex and two sides. So across from vertex D is side D, written in lowercase. Across from side A is vertex A. And across from side C is vertex C. Now we know how to completely label these triangles. The primary trigonometric ratios, sine, cosine, and tangent, can only be used when we have a 90-degree or right-angled triangle. So we need to have a method to solve triangles that are not right-angled triangles. Enter the sine law. Before we get to what the sine law is, let me show you where it comes from. Suppose we no longer have a right-angled triangle. So within this triangle, there is no 90-degree angle. How would we solve this? Before we begin trying to solve it, let's label our sides. So across from vertex C is side C, across from vertex A is side A, and across from vertex B is side B. Okay, we can actually turn this into a set of two right triangles. If we drop what we call the altitude, which is a line perpendicular to BC and goes to vertex A. This creates two right triangles. Center line here that we drew, H. Now I'm just going to highlight the two different triangles that we formed here, the two different right triangles. So we have one triangle in blue here, and we have another triangle highlighted pink right over here. Now, let's take a look at sine of angle B. So we know sine for a right triangle is SO, which is opposite over hypotenuse. And if we look at angle B here, we can calculate sine B is equal to the opposite, which is H, over the hypotenuse, which is C. Rearranging this, we're going to get sine B is equal to H over C. And if we multiplied C onto both sides, the C would cancel here. And we're going to get H is equal to side C times sine angle B. And you're going to be wondering why I'm doing this. It's going to make sense in just a second. So now we're going to take a look at the sine of angle C. Okay, again, when we're taking the sine of something, it's the opposite over hypotenuse. And we have this right triangle here. So our opposite for sine angle C is equal to the opposite, which is H, over the hypotenuse, which is B. So now I'm going to solve for H on this side as well. So we're going to multiply this side by B to get H by itself. And then what we do to one side, we must do to the other. So we're going to multiply this side by B. So the B's are going to cancel here. So we're going to get H is equal to side B times sine angle C. And now we'll see that we have H is equal to C sine B and H is equal to B sine C. So because they're both equal to H, we can make them equal to each other. So B sine C is equal to C sine B. And to get us to our sine law, all we need to do here is divide both by a common denominator to get rid of the B's and the C's on top. So we're going to divide both by B and C and B and C. And what this will do is it's going to cancel the B's here, and it's also going to cancel the C's on this side. And so what we're left with is sine C over side C is equal to sine B over side B. And if we do this whole process again, and we draw another H from A to B to C, and we do this whole thing again, we get our two different right triangles here, we're going to get sine of angle A over A is equal to sine angle B over side B is equal to sine angle C over side C. And so this is what we call our sine law. And this is where it comes from. And what this means is that the ratio of the sine of angle C over side C is equal to the ratio of the sine of angle B over side B, which is equal to the sine of angle A over side A. So there are two forms of the sine law. The one that we derived, which puts the sine of angle A over side A, sine of angle B over side B, sine of angle C over side C, and then the flipped version, A over sine angle A, B over sine angle B, and C over sine angle C. Now they're both exactly the same, and you can use them in any situation, but I would suggest that you use this one here to solve for angles. This one's good for solving angles. You'll have to do less cleaning up of the equations when you're solving. And this one here is good for solving sides. So the sine law can be used when you know two angles in one side, or when you know two sides in one angle. So let's try some examples of using the sine law. Example 2. Given triangle DEF with two known angles and one known side, find the missing values. So here we have triangle DEF. We're missing side F, side E, and angle F. And we can use the sine law here, and the key to know that you can use the sine law is that you have one known side, so this is side D here, and we have its corresponding angle, angle D. So if we know this is our key to using the sine law. So let's start plugging things into the sine law, and I'll show you how it works. So we have D, side D, over sine angle D is equal to, here we're going to solve for E, so we're going to solve for this one here, is equal to E, side E, over sine angle E. And we know what these numbers are for three of these values, so let's plug those in. So we know D, side D is 54. We know sine angle D is going to be sine of 34 degrees, is equal to E, the one that we don't know, over sine E, which is sine of 50. And now, before we start calculating what things are, we can actually clean this up on this side. We can get rid of sine 50 by multiplying it on here and multiplying to both sides. We're going to multiply this here. We're going to multiply it here. These are going to cancel, and we're going to just get E by itself. So we have sine 50 times 54, all divided by sine 34. And all these are just values that we can calculate in the calculator. So let's go ahead and do that. Let's see what sine 50 is. So sine 50 is equal to 0.76. So we can say 0.77 times 54, all divided by sine 34. Let's figure out what that is. So that's sine 34 is equal to 0.55 or 0.56 is equal to E, and now we just have to multiply and divide these values here. So let's multiply 0.77 times 54 divided by 56. I'm just going to do it all on my calculator here. So we have 0.77 times 54 divided by 0.56. And gets my answer here, 74.25. So we know E is equal to 74.25. And if we're just going to round this to the nearest meter here, it's just going to be 74. So we know E is equal to 74. Okay, now let's solve for F. So for F, we do need to find what angle F to find side F using the sine law. But we can find angle F using just properties of a triangle. Okay, so angle F here just has to be the remaining side angle for these. You know, all the angles in a triangle has to equal 180. So you know 180 is equal to 50 degrees plus 34 degrees plus angle F. 50 plus 34, that's 84, plus F is equal to 180. We'll move the 84 to the other side, as per usual, is equal to F. So 180 minus 84, let's see what that is. So 180 minus 84 is equal to 96. So angle F is equal to 96. Now that we know what angle F is, so this is 96, we can use sine law to figure out what side F is. So we're going to do that here. Let's find side F. And as I mentioned earlier, if we're looking for a side, it's best to use the version of the sine law with the sides on top. Okay, so we're going to use our key again from last time, which is D over sine angle D is equal to, now we're going to looking for F, and we know angle F, side F over sine angle F, and we can start filling in a lot of these values because we know what they are. We know D, side D is 54, sine D is sine 34. We don't know what F is, but sine F we know is sine 96. And what we can do is multiply sine 96 on both sides. And this will get rid of sine 96 here, and we're left with this, which is sine 96 times 54, all divided by sine 34 is equal to F. So let's calculate this, and we can just plug this all into a calculator to find out what these things are. So let's go ahead and do that. Let's clear this, and we have sine 96. So sine 96 is equal to 0.99, we can say that's 1, times 54 divided by sine 34, and we actually found out what that was 0.56 from what we did earlier, is equal to F, and let's just multiply these and figure out what this is. So we have times 54 divided by 0.56 gives us 95.9, or F is equal to 96 if we round to the nearest value. So F is equal to 96. So we know what side F is, 96 meters. And there we have solved this triangle. You could list them over here. So if you want to list what angle DEF are, so we have DEF, these are our angles. And we'll have sides DEF here. We know D, we said, or we know is 54 or 34. Side D is 54. Angle E is 50 degrees. Side E, we calculated to be 74. Angle F is 96. And side F is also equal to 96. And that's our solution. And that's how we use the sine law to find sides. Example 3. Given triangle DST with angle D equaling 47 degrees, side E equals 78 centimeters, and side S equaling 106 centimeters, find the measure of angle S. So this question here doesn't provide us with a triangle, so we're going to draw one in and then add all the sides and angles that we know. So we know it's triangle DST. So we're just going to draw a triangle here. It doesn't have to be representing like the actual degrees. We just need to know where things are just to give us an idea. So let's say this is D. We'll call this S. We'll call this T. So we know angle D is 47 degrees. Maybe I'll write that a little bit bigger. 47 degrees. Side D, which is opposite that, is equal to 78 centimeters. And side S is 106 centimeters. So S here is equal to 106. Okay, we need to find the measure of angle S right over here. And as you can see, we do have a key that's given. We know angle D is 47 degrees, and we know side D is also equal to 78 centimeters. So we could use this to find angle S in this relationship here using the sine law. So let's go ahead and get this started. Okay, so we know since we're looking for an angle, it's best to use the version of the sine law with the sine part on top, the angle on top. So let's do that. So we know sine D over side D is equal to sine S over side S. And we know these values. We know sine D is sine of angle D, which is 47 degrees, over side D, which is 78, is equal to sine S. We don't know what that is, but we do know what S is. It's given as 106. And I think you can see what we're doing here. All we have to do is multiply 106 on both sides. And then this is going to cancel this down here, and this is going to give us what sine S is. So let's figure that out. We're going to plug this in. So we need to figure out what sine 47 is. So let's get our calculator, and we'll do that. So let's figure out what sine 47 is. Here's my calculator. So sine 47 is equal to 0.73. So it's going to be 106 times 0.73, all divided by 78, is equal to sine S. Okay, and let's just run through this whole calculation here. So I'm going to multiply this by 106 and divide it by 78, which is 0.994. So sine S is equal to 0.994. Okay, so now to get angle S, we just have to take the inverse of both sides. So we're going to take the inverse of this side here, and that's going to get us S. And what we do to one side, we have to do the other. 0.994, and this is going to cancel this. So S is equal to the sine inverse of 0.994. So let's plug that into our calculator. So the sine inverse of 0.994 is 83.7. So S, or angle S, is equal to 83.7 degrees, and rounded, that's going to be to 84 degrees. So we know angle S here is 84, and that's what we were looking for. And that's the end of this question. Use the information given on the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100 kilometers. Okay, so we have to find the perimeter of this, so that means we have to add up all the sides to find it. Let's label all the sides here. So we know M would be this side here, B is going to be opposite angle B, which is here, and S is going to be opposite angle S, which is this. Now looking at this, we can see we have two angles and one side, but we're missing our key to using the sine law, which is having an angle and the opposite side. And so we need to find that, and we can find that using the principles of triangles. That is, all the sides have to equal up to 180 degrees. So let's find what angle B is by subtracting the sum of these two from it. Okay, so 180 is equal to 50 degrees plus 74 degrees plus angle B. 50 plus 74 is 124 degrees plus B is equal to 180. We're going to move this 124 to the other side. 180 minus 124 is equal to B. And 180 minus 124 is 56. So B is 56 degrees. So now that we know B, we have our key to solving this using the sine law. Okay, so we know the angle and we know the corresponding side. And since we have to find the sides of this triangle, we're going to use the form of the sine law where the sides are on top. Okay, so let's fill in what we know. We know B, side B over sine angle B is going to be equal to, let's solve for S here, S over sine angle S, and let's fill in this data. So B we know is 1800 kilometers. Sine B is going to be the sine of 56 is equal to S, which is what we're trying to find, over sine of angle S, which is 74. And to solve for S, what we're going to do is we need to get it by itself, so we have to multiply both sides by sine 74 degrees. These are going to cancel, and then we're going to get S by itself. So sine 74 times 1800 divided by sine 56 degrees is equal to S. So let's figure out what these numbers are in our calculator over here. So let's pull that up. So let's find out what sine 74 is. So sine 74 is equal to 0.96. So this is 0.96 times 1800, and then we just have to find out what sine of 56 is. So let's do that here. Sine of 56 is equal to 0.829, so let's say to two decimal places, 0.83 is equal to S. Okay, so to solve for what side S is, we just have to solve for what this is here. So 0.96 times 1800 divided by 0.83. So let's just do that in our calculator. Okay, so let's clear this. So we have 0.96 times 1800 equals this divided by 0.83, which is equal to 2081. So S is equal to 2081. But the question says to determine to the nearest 100 kilometers. We're going to round this up to the nearest 100 kilometer. So this is going to round up to 2,100. So S is going to be 2,100 kilometers. Now, let's try finding side M. So we can use the same ratio that we've had here. Side B over sine B is equal to side M over sine of angle M. And let's start plugging in some values into this. So we know side B is 1800, sine of B, sine of 56 degrees, is equal to m over sine angle m, which we can see is 50 degrees. Okay, so we could rearrange this if we multiply sine 50 on both sides. So let's divide that there. This can cancel out here, and let's just rewrite this. So sine 50 times 1800 divided by sine 56 is equal to m. And we know some of these numbers already. Sine 56 we've already calculated over here, so it's 1800. We know this is 0.83. We just have to figure out what sine 50 is. And let's figure out what that is here. Let's clear this. So sine 50 is equal to 0.0766, so we'll say 0.77. And we just have to multiply all these things together and divide by 0.83 to get our answer. So let's go ahead and do that. So we have 0.77 times 1800 divided by 0.83, which is equal to 1,669. So m is equal to 1,669. And we just have to round that up to the nearest hundred, and that'll be 1,700. So this is our m value, 1,700. So now we have all three sides, 1,800, 2,100, and 1,700. We can add them all together to get our perimeter. So perimeter is equal to 2,100 plus 1,700 plus 1,800. Let's add those up. So we have 2,100 plus 1,700 plus 1,800, which is equal to 5,600. So our perimeter is equal to 5,600. So therefore, we can conclude the Bermuda Triangle has a perimeter of 5,600 kilometers. So that's our solution there. Example 5. A cottage under construction is to be 12.6 meters wide. The two sides of the roof are to be supported by rafters that meet at a 50-degree angle. How long should the rafters be if they are the same size? So let's start this example with a diagram. So we have a cottage, and it has a roof on it that we're building. Here's our roof. And these two parts here are the rafters, these parts that support the roof. And we know the house is 12.6 meters wide. And we know the two rafters meet at the top at an angle of 50 degrees. Okay, so we want to figure out how long these rafters are, and again, these rafters are equal in length. So we can see we have one angle here, and we have the associated side, but we don't have any of the other angles. How could we figure this out? Well, one of the clues is that this is an isosceles triangle, where the two sides here are equal. That means these angles down here must also be equal. So if we know if we added 50 plus these two angles here, it should equal 180. So we know 180 is equal to 50 plus x, which is 2x. So we can figure out what this is. Let's move the 50 over to this side. We have 180 minus 50 is equal to 2x, and 180 minus 50 is 130. Now to get x by itself, we're going to divide both sides by 2. These are going to cancel here. 130 divided by 2 is 65. So x is equal to 65, so we know this is 65 degrees, and this is also 65 degrees. Okay, so now we're getting somewhere. So now that we know a side and an angle, and another angle, we can use the sine law. let's label some of these sides. So since we said this is angle X, we'll call this side X over here. And since this is the angle where the roof meets together, we'll call this angle R, and then this would be side R. Okay, and since we're looking for a side X, we're going to use the sine law that puts the side on top. So let's start plugging this in. We have R over sine R is equal to X over sine angle X. And let's plug in some values here. So we know R is 12.6. Sine R is going to be the sine of 50 degrees is equal to X. And sine X, angle X is 65 degrees. Okay, and if we want to get X by itself, we're just going to multiply both sides by sine 65. These are going to cancel here, and we're going to get X by itself. So sine 65 times 12.6 divided by sine 50 degrees is equal to X. And again, we can just plug these values into the calculator to get actual numerical values. So let's try it out. So we have sine 65, which is 0.906. So we'll say 0.91 times 12.6 divided by sine 50, which is sine 50, which is 0.766, so we'll say 0.77 is equal to X. And now all we have to do is plug this into a calculator and solve for what X is. So let's go ahead and do that. So we have 0.91 times 12.6 divided by 0.77. And we're going to get our rafter length, which is 14.89. So X is equal to 14.89. And so that's going to be the length of the rafters. So approximately 14.89, or we can round up if you want to 15 meters. So we can say, therefore, the rafter should be 15 meters each. Sometimes you'll have to use both sine law and primary trig ratios. Example 6. Omar and Ritu are determining the height of a cliff they plan to climb. They are 18 meters apart on the same side of the cliff. Sighting along the same line, Omar views the top of the cliff at an angle of elevation of 23 degrees. Ritu views the top at an angle of elevation of 29 degrees. How high is the cliff? Hint, draw a diagram. Okay, so let's draw a diagram of this situation here. Okay, so we have our triangle like this. We have Ritu on one side and Omar on the other, and they're both looking up at this cliff at different angles of elevation. Okay, so we know Omar is looking at 23 degrees, and Ritu is looking at it at 29 degrees. And we know that they're 18 meters apart. We want to figure out how tall is this cliff, this distance here to here. So how do we solve this problem? Well, first of all, we can see there's a big triangle here that we're looking at. So let's deal with this one first. In order for us to use the sine law, we need to know at least this angle here, or one of these sides. So we can solve for this angle using properties of triangles. So we could use our key value, which is this side and angle here. So we know side C over sine angle C is equal to side O over sine angle O. So C we know is 18 meters over sine C, which is sine 128 degrees, is equal to O, which we're looking for, over sine O, which is Omar's angle of elevation, which is 23 degrees. So this is sine 23. And to get O by itself, we're just going to multiply sine 23 on both sides. These are going to cancel, and we're going to be left with this. Sine 23 times 18 is equal to O, and these numbers we can just calculate in a calculator. So let's bring that up. Let's calculate what sine 23 is. So sine 23 is equal to 0.39. And then we just have 18, and then we'll figure out what sine 128 is. So sine 128 is equal to 0.788 or 0.79. And this is all equal to side O. And let's finish this off here. We'll just plug these all into this calculator. 0.39 times 18. So 0.39 times 18 divided by 7.9. Or 0.79, I should say, which is equal to 8.88 or 8.9. So O is equal to 8.9. So we know this distance here is 8.9. Now, we're actually going to separate this into another triangle to solve for what this height is, and I'll show you how. We're not exactly sure what this distance is over here. We're not exactly sure it's halfway between Omar and Ritu, so we can't use that as a reliable distance. So we're going to have to use the hypotenuse, and we're going to have to use this angle here and find what this is here. So let's redraw this triangle and just half of it over here. So we know from Ritu's side, she's looking up at 29 degrees. We know this side is 8.9, and we're looking for this side over here. We do know it forms a 90-degree angle. So we can see this is just a right triangle. So we can use the primary trigonometric ratios. So this is angle C over here. And looking at this, we can see we're looking for the opposite. So this is opposite, and we have the hypotenuse. And so if we think of SOHCAHTOA, we're going to be using, we want to find opposite, and we know the hypotenuse. So we're going to be using SO. So we can say sine 29 degrees from over this side is equal to opposite, which we're looking for, over hypotenuse. And we know the hypotenuse on this side is 8.9. Now, let's solve for this. So we can just solve for sine 29 and multiply both sides by 8.9. Actually, we'll multiply 8.9 first, like this, just to get rid of it over here and here. And we just have to figure out what this is to get this distance here, the opposite, which is the height. So let's go ahead and do that. So we have 8.9 times sine 29. So let's figure out what sine 29 is. Sine 29 is equal to 0.484. And we're going to multiply this by 8.9, which is equal to 4.31. So the opposite is equal to 4.31, which is equal to our height. So this distance here is going to be 4.31 meters. And that concludes our question here.